Hi everyone, and welcome to our latest webinar. My name is Peter Sonnenschein, and I'm the head of sales of the distribution department at Lumitronics. And today's webinar, the title is Optimize Your Light, is all about optics and how you can optimize your light with using optics in indoor applications. So let me just give you the exact title. I'm truly happy that it's not only me speaking to you today, but to have our three valued partners, LED, Carglass, and Gajon, today with me to present in this particular webinar. And we felt it was about time for a dedicated optics webinar. And I do believe it is a great chance for you who are attending the webinar to have three optics manufacturers being together presenting in one webinar. So this is the slide I wanted to show you. As you can see in the picture, we are not only a distributor for different optics and LED brands, but we also see ourselves as a specialist for developing and manufacturing light sources, and thus to offer an all-from-one source philosophy to our customers. To be able to do exactly that, we need the best possible partners to add the best possible values to our portfolios with LED modules, controllers, etc., etc. And optics is definitely a big part of that. The variety of possible indoor lighting applications is vast, lasting from warehouse lighting with heights of 5 meters or more, can be office lighting with UGR smaller than 19 requirements, can be emergency lighting, can be shop lighting to highlight a certain product, or it can be ambient lighting with color mixing options. All of these just mentioned examples need optics in order to reach for the perfect result. As I already said, here at Lumitronics, we are a specialist for developing light sources, and the usual way for us is to start with designing a light source and then choosing an optic to fit the light source. But we learned that the other way around, by starting with the optic and designing a light source fitting the optic, can be as effective. I'm sure in the upcoming presentation we will learn a lot about the lighting products, optics from each manufacturer, as well as seeing some good examples of fitting LED modules and optics. Before getting started with the presentations, let me give you some general information on the webinar first. The webinar will be recorded, and the recording and the presentations will be published afterwards. You can raise questions in the Q&A section, and we'll answer these questions in the Q&A sessions after the presentations. All questions that cannot be answered in the Q&A session because of the time limit will be answered by email after the webinar. The first presenter of the webinar today will be Michael Berger from LED. And Michael, if you're ready, the stage is yours.
Thank you, Peter. I am ready. So I hope that everybody can see my screen now. Peter?
Yes.
Okay, good morning, everybody. So my name is Michael Berger. I'm key account manager at LED, a Finnish optic manufacturer. And I would like to thank Lumitronics for arranging this webinar and start with following agenda. So I will give you a brief overview about LED optics and our portfolio. Then also what means good light for office lighting and how LED has found a good solution for that. And finally, we want to present a new universal board for single optics, which Lumitronics have come up with recently. So LED, as an optic manufacturer, has classified different kind of optics we are providing. So that could be a variety of single lenses in different diameters and tasks. multi-array lens systems. We have linear lenses, we have reflectors from aluminum and plastic. We have street and area lighting optics dedicated for this market, as well for high bay lighting. Then we have also connectors and of course customized solutions we can offer here as well. In particular, we have divided this into indoor and outdoor lighting. So there are certain application areas such as retail, office, industrial, architectural lighting, sports, horticulture, and special lighting in the indoor section. But also for outdoor, we are covering street light area, tunnel transportation, architecture, sports, and special lighting as well. In today's pandemic situation, of course, UV becomes more and more an interesting topic. And also here, we can provide a variety of different optics for different tasks made from special materials to support UVA, UVB, and also UVC high power LEDs. And as you can see, that could be also arrays. It could be also single optics and reflectors. Again, they all have different tasks and sizes, form factors. Of course, we also have quite a variety of linear luminaires or luminaires examples here, starting from the left to the right with Linda or extrusion optic family, Claudia, linear GC and GC2 is not here, but will come soon, and then also Frauens as a 3R optic. These are all different kind of families we are offering in different kind of form factors, different lengths. So these are extrusions or molded optics. Within the family, we offer a variety of all kind of different beams from 60 to 110 degree, asymmetric, double asymmetric, oval, wall grazer, etc. They are made from special materials, from PMMA or even polycarbonate. Some of them also are available as IP versions, so US protection. Then we have also optics which have free LED pitch. Some of them needs a fixed LED pitch, and this has to do with glare control, where you need a fixed LED pitch. And some of them can use standard Saga compliant boards, and some does not need but can also use. Finally, you can see some of them are more glare optimized and others are not so much, but this also depends on the manufacturing technology. So in terms of office lighting, we would like to understand what an office worker would prefer in terms of office lighting. And there was a study, I think in 2014 from Zumtobel, with about 2,000 participants, and it came out that they would like to have a direct and indirect lighting, and it should also have the ability to control this, and they would like to have brighter workstations, probably with 800 lux. In smaller offices, they would prefer some warmer tones, and in larger offices, they prefer cooler tones, so color temperatures. And as a result, the LED conversion is happening more and more. New technologies like LED, smart lighting, controls, and human-centric lighting are in focus nowadays. So LED is enabling the new technologies by having tunable-wide support for human-centric lighting and making designs that allow miniaturization and high efficiency that enables you to get most out of the LED. In office lighting, especially glare and UGR, unified glare rating, is a big topic nowadays. And to understand this a little bit more, I give you some information here. So we say there are three types of glare, which then have influence of disability and also discomfort. So type A is basically bright lamps or light which goes directly into your eye and blinds you basically. It is measurable and has a clear effect to performance. Category C, B and C, they are more reflection of light on specular high gloss surfaces such as tables or even the screens of your monitor. And this, as a result, this could be disable you for visual performance. It has an effect on that, and it can be measured. But also it can be discomfort. So it's of course a subject evaluation. If light feels uncomfortable and it not necessarily affects your visual performance, but is just uncomfortable. So in office lighting, this unified glare is rated by below 19 as a value. So everything above 19 would be uncomfortable and not recommended. In the field of vision, our eyes can be specialized here in zones, like the central zone. You have a paracentral zone, you have a near peripheral zone, you have the mid peripheral and the far peripheral zone. And 50 to 60 degree is the upper limit, which is considered for glare. So it's somewhat individual, and different sources gave different angles. What does it mean? If you look here to the different persons standing in different positions under or in the ratio to the luminaire, the surface luminaire, or we call it also dark light. So the requirements are surface luminance can be not more than 200 candela per square meter above 60 degree. So it means that virtually no light should be above 60 degree. The light source is not visible. To make sure glare is not an issue, the light source can be seen in the field of vision 53 degree upwards. But no significant light intensities can appear above 30 to 37 degree potential glare angle. So this area. So what does it mean in concrete? Person A is inside the beam and but cannot see the luminaire unless, of course, is looking upwards. So he will not get blinded. There's no glare. Person B can see the luminaire, but in case light intensity of the beam is limited above the potential glare angles of plus or minus 37 degree, the glare is also not an issue. And person C can see the luminaire, but in case it is dark light, he cannot see the light source, so there's no glare. And this means with the dark light, we have a dark light concept called DAISY, which I will give you later on some introduction. So there are some ways to reduce glare, of course. So one is to limit the light intensity above the potential glare angles. This is point one. You also can increase the surface of your luminaire, which means a more uniform surface luminance with the same lumen output, which makes it also more comfortable to look in instead of having single spots. Then, of course, you can shade your luminaire, or you have some kind of shielding around your luminaire. You can also reduce the lumen output, but of course that might require adding more luminaires to achieve the required lux levels in the area. Then, of course, the placement of the luminaire towards your task, avoid glare on the task area. So maybe also increase ambient light. And then finally, of course, use more indirect light as well, so that the contrast of just your luminaire is not so given. So take visual performance, visual comfort, and visual ambience into account to achieve the right light for a specific space. And as you can see, the light level, the glare, direction of the color of the luminaire, shadows, color rendering, and uniformity, they all work together. As a solution, I would like to introduce you DAISY. This is our dark light concept based on a lens and with a shielding shade. And it's a premium for office lighting. In particular, I would introduce DAISY Mini. It's the smallest and the most efficient dark light optics in the world. And we have quite a huge range of different optics suitable for that to achieve different beam angles, of course. They are available in clear and diffused material. They can work with tunable white solutions. We offer them in clear and diffused material, so also color over angle issues is not given. They can be used in retail lighting, office lighting, hospitality, and also accent lighting. And you can use even 1 or even 2 LEDs per optic. So you can make a wonderful 2-mil wide mixing chamber here as well. Typically available in 1 feet length, so 280 millimeter and about 21 millimeter in width, and can be added into every length you would like to achieve here. So important is that we can achieve the UGR below 19 levels. So Lumitronics has designed a specific board for that. Here's the link. You can find it on the website. It contains 14 LEDs, so it has 2 LEDs per, no, it has 1 LED per optic in this case with 4000 Kelvin color temperature. And in combination from our website, I took this screenshot here. You find also information about how this optic performs with that PCB. So you find information what kind of shade was used, you find the beam angle, you find the peak intensity, the efficiency, how many LEDs per optic were used, the color temperature, and also you can download data sheet and also photometric files here. There's an indication if this is measured, or sometimes you find indication it's simulated. In this case, it's a measured result. So for the photometric two in one general wide from Chia, which they used on that board. What you need to have combination, the optic. It could look like this is a big Daisy, this is Daisy Mini. As a pendant light, you can also use some uplight up front, also to reduce the glare and to control the glare in a better way. Yeah, very, very common right now in the market. Finally, usually when we have awful lot of single optics available, and it's hard to test them if you're not sure if this works for your application. So Lumitronics have designed this universal board, which has all kind of hole locations set up here. So with a color code, you can identify which lenses with their pins attached would fit into which hole. So you can use it easily, test the optic before you create your own PCB, for example. So that is quite useful and recommended when you are not sure which kind of optics you would like to use. Take this board and use the different color codes to identify which lens fits into this area, and then you can easily use and test it. That was everything from my side. Thank you, everybody. I will now forward to Bernie Daniels from Carclo.
You're on, Bernie.
Thank you, Michael. I'll just my presentation up. Everybody see my presentation?
Yes.
Cool. So, hi everybody, I'm Bernie Daniels. I'm the OEM sales manager at Carclo Optics, and I work with our OEM customers and our distributors, and I cover both commercial and technical inquiries. So I've been in the LED lighting industry for over 16 years now, and I've been with Carclo Optics for nearly 10. So before I get started, I'd just like to thank Lumitronics for inviting me to present to you today. Hopefully I can share some useful information with you. So just a little bit about us. We're a UK-based company founded in 1936 by a gentleman called Arthur Kingston. He was the inventor of the plastic lens. And in 2003, the specialist LED team was created. And this was to design and manufacture secondary optics for the very first high power LEDs. We have offices and manufacturing facilities in the UK, the US, China, India, and the Czech Republic, and we design, test, and manufacture in-house. Just a brief product overview. As you can see, we have 4 families of TIR optics, ranging from 10mm to 30mm in diameter. Each family has a range of narrow, medium and wide and elliptical beams. And they also have a range of surface finishes, so plain, frosted and ripple. The surface finishes not only help to achieve the required distribution, but they also reduce unwanted characteristics like colour over angle, artifacts in the beam, chip imaging, that sort of thing. Next, we have our 60mm catadioptric. So this is an ultra narrow beam part. It's currently only in a family of one, but there is a smaller version coming out later on this year. And this is designed specifically to produce a very, very narrow beam. So it would take like a high-powered small die LED down to about 3 degrees. Next up, we have the Hubbles and the mini Hubbles. These are freeform optics, and they were designed mainly for street lighting. But they're also useful for other applications such as signage, and as we'll see in a little while, for EN 1838, which is emergency lighting. Then we have the Silicon S1 family. In this family, we have an ultra narrow, a narrow, a medium, and a wide beam. And these were designed to work with COBs with up to a 27mm LES. The bases are compatible with many Zarga compliant 50mm interconnects. The ultra narrow beam was really designed mainly for retail applications, to take something like a 9mm LES cob down to about 10 degrees. Then next we have the strip optics, and as the name implies, these are linear extruded optics. Currently there's a narrow, medium and a side emitter in the family. But there will be 2 more versions coming out probably within the next 2 to 3 months. Up next is the 33 array family. So these are for use with Zarga compliant 3x11 modules or 3R boards. In this family, we have a narrow, a medium, a wide, 2 double asymmetrics, so there's a 40 and a 25 degree. And coming out probably in the next month will be an ultra wide version of around about 120 degrees. We also have a baffle and reflector system for the medium beam, which is the 60 degree, and this reduces the glare down to about a UGR of 16, which means obviously that you could use it for schools and office type applications. Then next we have our bubble optics. So these are ultra wide beams. 120 to 180 degrees. Many have a backwing distribution, which gives a high uniformity over wide areas. And then finally, we have the reflector families. So this is quite a small range of reflectors that we have, but we've just recently completed 8,000 hours UVC testing with the Archimedes family, which will then give us a low cost, small form factor UV solution. So, having seen the standard range, we're now looking at optics which are compatible with Lumitronics modules, specifically for indoor lighting applications. And for this, we're showing the PowerBar V3 and the Ventrix modules as examples. So on the right, we have the range of optics, 10mm optics that are compatible and could be used with this board. And then looking at each in turn. So here we have a 10mm narrow spot TIR. This is part number 10412. It has a 90% efficiency and a beam angle of 15 degrees. As you can see, it has good uniformity and quite a soft cutoff. Has many applications, but specifically for indoor use. It could be used for accent lighting or infill, task lighting, or even wall washing or wall grazing. And then next we have a medium spot, which is a frosted optic, part number 10413. Has a 92% efficiency and a beam angle of 26 degrees. Again, very good uniformity, and again with a nice soft cutoff. Realistically, this could be used for any kind of general interior lighting. But one example might be sort of under unit lighting for kitchens. Then we have the wide spot frosted, part number 10414, 70–80% efficiency, with a 33-degree beam angle. Again, very high uniformity, again with a nice sloping cutoff at the end of it. Really, this could be used for any kind of general indoor lighting. Next is the elliptical ripple lens, part number 10415, 87% efficiency with a 45 by 16 degree beam angle. Again, nice uniformity on that. This would obviously be useful for lighting corridors and walkways, but also for accent lighting, over desk task lighting, and again, wall washing and wall glazing are potential applications for it. And then finally, we have our medium beam spot top lens TR, part number 10417. So this is a TIR optic with an additional lens built into the top surface. Has an 85% efficiency and a 14 degree beam angle. The performance is very similar to the 10412 that we saw originally, but from the spot image you can see it has a much sharper cutoff. Also, you can see it here on the intensity cross section. So it could be used for the same kind of applications as the 10412, but it has far more control and a lot less light spill. So next we're looking at potential applications for the Eventrix models. We're going to talk a little bit about emergency lighting as one possible use. So emergency lighting has three main categories, and these are escape routes, anti-panic areas, and high-risk areas. So escape routes basically cover corridors and walkways, anywhere where you need access to evacuate a building from. So just as an example, we've come up with some theoretical scenarios. So we're looking at a corridor that's 60 meters long, 4 meters wide by 4 meters high. And in this corridor, we've placed 3 luminaires at a 22 meter spacing, mounted at 4 meters. And for this, we're using the Eventrix 2x2 module, combined with our mini Hubble Type 1 optic. So the requirement for EN 1838 for escape routes is greater than 1 lux. And as you can see in this scenario, we're achieving 1.5 lux, which potentially means that we could actually run the luminaires at lower power, or potentially move them slightly further apart. And also the uniformity requirements is a 1:40 ratio, and we're actually achieving 1:1.7, so it's considerably better uniformity than is actually required. So again, potentially the fixtures could be moved further apart. Next, we have anti-panic areas. So this is basically anywhere where people would be congregated. So it could be an office, a restaurant, a canteen, a hall. And for this scenario, we've come up with a room size 30 meters by 30 meters by 4 meters high. We've lit it with 9 luminaires in a 3x3 configuration on a 10 meter spacing. These are mounted at 2.8 meters high, and again we're using the Eventrix 2x2, but this time we're looking at a Carclo Mini Hubble Type 5 optic. So the requirement for EN 1838 is greater than 0.5 lux. And in this scenario, we're actually achieving 1.1 lux. I will point out as well that the Eventrix boards have been severely underdriven in these scenarios, because all emergency lighting would be battery powered, and the lights need to stay on battery power for a minimum of 1 hour. So obviously power consumption is a major consideration in this. So as I say, the requirement is 0.5 lux, and we're actually achieving 1.1 lux. Again, the uniformity is 1:40, and we're actually achieving 1:2.35. So again, it's a pass. And then finally, we have high risk areas. So these are basically hazardous areas where there could be machinery, vats of liquid, basically anything that could present a danger to movement. The specification for this is less well defined, as the lighting is very specific to each possible environment. Mainly it comes down to a minimum of 15 lux and the glare. So what we've done is we've actually looked at the glare, and we've come up with three optics that would actually hit the requirements for that. The lux level obviously would be dependent on the environment it's going into, how many fixtures you're using, and also how hard you're driving those fixtures. Here we have the different Ventrix configurations and the optics that would fit with them for emergency lighting type applications. And then the final piece of information I'm going to share with you. So Optics Select, which is on our website. So down here, www.carclo-optics.com. Here you can find all the information on the optics that we've just seen. And from here you can view and download data sheets and the IS files for each LED and optic combination, 2D drawings, and 3D modules for mechanical assembly. That just leaves me to say thank you for your time, and I'll now hand over to my fellow presenter, Laurent from Gagio.
Thank you, Bernard. Okay, so let's start sharing the presentation. Okay, so first, I think everybody can see the screen now.
Yep.
Okay, thank you. So first of all, thank you very much, Bernard, for your presentation, and a special thank you to all of the Lumitronics team. I mean, Alina, Paul, and Peter. Gajan has been working quite distantly with Lumitronics for a couple of years, but I'm glad to say that we are now part of the official Lumitronics portfolio among optic products. So thank you for that, first of all, and thank you for inviting Gajan to such a webinar, which I think is very valuable for everybody. So let's start. Topic I'm going to address today is to share with you some struggles we had in the past with color mixing, optics development, and especially on the qualification side of the performances, and how we sorted this out, and how this way we sorted out could possibly be a tool for you to select and pre-qualify some color mixing optics and LED combination. So topics for today are how to qualify the color mixing quality, which was our struggle in the beginning, and how to predict color consistency among your projects or your discussion with customers on color mixing based optics or solutions. Where did we start from? In the beginning, Gajan has been involved into optical injection and optical system development since 1948 for the company age, and I would say since the 90s for the optical side of our business, which is now most of our turnover. And we always have been, in a way, specialized in both development fields, one being the narrow beam optics, the other one being the color mixing, where we had a lot of activity and still have a lot of activity in the entertainment business. And we see a clear trend from all this color mixing technology that was used first in the entertainment, then into the architectural application field, is now jumping into indoor office lighting and application. And our difficulty was to honestly address the quality of the color mixing of a given beam. And in the first place, it was mostly a research and development struggle for us to be able to fairly address the result in between different options, different injection parameters, or different designs. So we needed a tool to address the color mixing performances and to measure it in the fair way, which tool we didn't find. For what kind of application could such a tool be useful? Obviously, I mean, for any static white luminous, we know that some LEDs will produce some color defects like the color over angle, meaning the color temperature not being consistent among the emitting angles of the LED. So even the white luminous can find some interest, and the white related developments in general can find some interest in being able to address the color consistency of a beam. It's of course very relevant for any human-centric lighting, cold white, warm white, tunable white, LEDs, whatever you call that, and of course for any RGBW color mixing optics or applications. The question for you, I mean, as light designer, light developer, would be how to pick a combination in between LED cluster, and an optic that will reach your target or your customer's target in terms of color mixing consistency. Let's just go back for a while on how the human eye perceives the colors. So the visible spectrum goes from 380 nanometers to 780 nanometers. So it be in between red and violet. So before infrared and before ultraviolet. Our eyes actually have sensors called cones, which will react to three very distinct stimuli, X, Y, and Z. And all of the colors we can see with our eyes and brain are represented in what is called a two-dimensional color space. You can see here on the right, which is a representation, long story short, of all the colors we are capable to perceive and to distinguish. How do we distinguish color? What makes your eye, and what is the mechanism and phenomenon that will lead us to say, okay, this is exactly the same color, or the color is consistent, or I can see differences in the colors. So scientific approach has led to what is now called the macadam ellipses. Here you get some examples of these black ellipses among the color spaces representing the macadam ellipses. To get a very clear overview of what a macadam ellipses represent in the real world, it means that all of the colors, all of the different color variations that will be within one ellipse, our human eye will not be able to distinguish any color variation or any color shift. So the macadam ellipse is the space within the color space where we are not capable of distinguish any color shift. Here, the ellipses are plotted on what is called the CIE 1931 color space diagram. They are represented right now for, I would say, visibility improvements has been affected by the 10 times ratio, so they are way smaller than that in the real diagram. One of the problems the industry has been facing with this representation of the ellipses is that you can see they are not very consistent. They don't share the same size, they don't share the same shape. Some are rounder, some are more elliptical. So it was not the perfect way to represent the ellipses. So a new color space representation has been brought called the CIE 1976. Without getting into details, what we can see is that on the right part of the screen, when we then try to represent these macadam ellipses, color spaces where we can see any difference into the CIE 1976 diagram, they are way more consistent in size and they are way more consistent in shape. In other words, they are more rounder. So nowadays, we will strongly recommend, and the industry has switched to the CIE 1976 diagram to deal with color shift and color consistency. So we had to build something. We wanted to measure the consistency of a beam. Could be a projected beam on the wall, or could be like a wall grazing application, or any indoor application you can figure out where the color consistency might be a question. So we want to qualify the color homogeny of a light beam using macadam ellipsis steps. We had to name it. So the name is the color consistency index we contract into the CCI internally. The higher the CCI will be, the worse the color consistency will be, and the worse the result will be. Some examples here. Picture taken from a LED manufacturer communication package. Because LEDs have been used, LED manufacturers have been using the macadam ellipses for a while for binning/sorting of LEDs among production variations. So we see that two steps will be barely visible by the human eye. At 3 steps, I don't know how good your display and picture quality is, but we can start to see here, among here, that these two beams does not really produce exactly the same color. And within 4 steps, there is an obvious and clearly visible color shift in between this LED and this LED. And we can also see, by the way, that in that particular picture, the color consistency of the beam, this is a very simple reflector, basic stuff, which is not part of our product portfolio, by the way. We can also see that the color consistency is not very great. We have something more reddish in here. It's pretty yellow in here, becomes slightly pink on the edge. So even if here we have a color consistency difference in between two LEDs, we also have within the main beam some very visible color consistency issues, which could be possibly a problem for your application and customers. How do we do that CCI measurement and extraction? It's pretty simple. We use a high resolution, very high sensitivity color camera. We spread the beam among the wall. We take a picture of this beam. So this is a representation of one of our collimators. This is how the image could look in a very simplified way and monochromatic way, by the way. And then we apply some math to that. Long story short, it's mostly standard deviation. There is, of course, some filtering in the process to get rid of the data that is not relevant. Could be the level of light, could be outside of the beam angle. I mean, the D10 beam angle, which we don't really consider for the CCI measurement. If you want some more details about how we proceed, I mean, technically speaking, about the math themselves, feel free to ask. It's not something we want to keep for ourselves. I think you understood that basically we developed that for our own internal research and development use, but we had great feedback from customers where we presented that, and they are now using that on an everyday basis for their development. So there is nothing we want to hide. There is no patent for Gaussian or anything like that on this measurement protocol. So we are ready and willing to share with anybody wanting to use it, understand it, or maybe challenge it. Some guidelines about how to interpret some results we're going to talk about later. We're going to always express the color consistency in numbers of steps of macadam ellipses. So one step would be, I would say, perfect color mixing. Anything would be visible to the eye. When we are in between 2 to 4, depending on the application, the beam could be considered as good enough. We'll say it's hardly visible to the eye, then it's a matter of interpretation. It depends on the eye, it depends on the application, and it depends on how picky the final customer, the final decision maker will be regarding color mixing. And that's exactly the era where we were stuck without having a fair measurement, because from 2 to 4, results can look pretty similar to the eye, but technically speaking, they are not very similar. And if we go together above 5 ellipses, there would be a clearly visible color shift on the resulting beam. So just some guidelines. Perfect will be 1. Good enough for some market will be between 2 and 4. Usually 2 to 3 ellipses will match customer specification, but it depends. Sorry, my phone is ringing. Then, how can you use this data? What we do is that among our standard optics offer, we have a selection tool online on which there are many criteria you can pick from. I mean, form factor, material, RGBW, tunable white capability, UV capability, size of the optics. Anyhow, there are, I think, like 25 criteria you can play for to select your optics. We measure all of the LEDs we have with all of the optics, and we publish the corresponding measurements. So you will find very common measurement, FWHM, FWTM, sometimes 2 values when there is an elliptical optic involved. But we now on also publish the result in terms of color consistency index. So knowing what LED you want to use or your customer has been validating or willing to use and what type of application you're dealing with, you can already predict how good or how bad the color mixing will be. This example here I'm showing you is based on the E19A from Nishia cluster for tunable white made by our friends in Lumitronics. So it's a real-world example where you can already figure out what would be the result of the so-called LLC25N from Gaussian using that particular LED. We publish that for all of the LEDs we have. This is not something we can simulate. You will find sometimes on our website some simulated data that will appear in blue. It's a matter of gaining some times given the
the rate by which the LED manufacturers are pushing out new products, but we strongly prefer measurements. We had some bad experiences and some disappointment, let's state it as it is, on customer side, using only simulations. So simulations are great because they are fast, they are not very accurate, especially for very narrow beams and especially for color mixing, where there is at this point no real tool for color mixing consistency simulation. And gotta say that is something we are already working on. So what are these LSC25, whatever you don't know about? These are our latest generation of 32mm color mixing collimators. They come in various light distribution. And as I was telling you, we are quite specialized into narrow beams and color mixing. So we usually release a bunch of narrow versions of the collimators. Here, as an example, all of these 32mm color mixing optics will be compatible and will provide great color mixing results and consistency with the Smart Array Q4 modules from Lumitronic. And we here have 3 different narrow beams. We have a proper narrow beam. We have a color beam, which is something the C you will find in many of our product range. Let's say it like that. Color beam is not necessarily the most narrow version of our collimators, but it's the best compromise we've been able to come out with, considering it has to be narrow, but still provide a good color mixing consistency. And in that range, we also have a dedicated version for wall grazing, which is the 25G, and then a medium, a wide, a very large, and an elliptical version. Pretty standard stuff. If there's anything you want to try with these, you can request Lumitronics. They have samples available, and if they don't have, I'm going to ship them to them, and you're going to be able to make a real opinion based on this possible combination. Another product range that might be relevant to discuss the color consistency index and color mixing topics in general is the latest generation 45mm color mixing. So it's, I would say, basically the same technology. It's a bit more, I was about to say it's just a form factor, shrinkage, or swell of the optics. The optical engineer will not be very happy about me telling that. But what I can tell you is all of these 45 and 32mm optics are based on the same concept, for which Gaussian has a patent on the color mixing technology side of the design. And we will find here quite the same logic. Here we have 5 different I would say narrow beams. Some are ultra narrow beams. They won't be the best one, of course, for the color mixing. They are more intended to serve application where the on-axis intensity is the key. So maybe not such of a deal for indoor lighting. It's more like searchlight application or very long-range lighting markets we are serving with this. But for narrow beams, I would say proper narrow beams, we already have 3 versions. They will all provide different color mixing versus beam angles versus LED compatibility compromises. And we also have a LLC59C for color beam versions. This LLC59C has been maybe one of the most successful collimators from Gaussian's standard range. We launched this product, it was, I think, 2 years ago, and it's constantly ramping up in sales, and we constantly see new application for this product. We started with entertainment stage lighting. We are now fully into architectural application, and we see a lot of customers starting to use these optics for spot lighting indoor, could be shop lighting, could be office lighting. We also have some customers integrating these optics, I mean 32 or 45, into custom orders for linear application. We can also provide as custom parts for the market. And that's it for me today. Thank you very much for your time, and thanks again to Lumitronics to giving us the opportunity to present our technologies and products.
Thanks, Laurent. There's actually one question for you, Laurent. It's Theo asking, if the color changes very gradual over a larger distance, can't you allow for a bigger color shift in the Adams ellipse?
I'm not sure to get the question. If we're talking about specification, which means that we know by experience that what's going to happen on the extreme edges of the beam, I would say outside of the main beam, might be where there is we are the more likely to see color shift, because it's an area where the optical engineers cannot really control the light, or are not intended to control the light, because it's outside of the main beam. So straight answer is that yes, we usually see more color deviation outside of the D10. I would say the FWTM, meaning the beam angle corresponding to 10% of the maximum intensity. There is always a lot going on in color mixing outside of this. Usually, it's not a roadblock or a showstopper for us, because most of the customers and light designers we're going to be working with are mostly focusing on the main beam, and among the main beam, they are mostly focused on the D50. Being the FWHM, which is the equivalent beam angle to 50% of the maximum intensity. So in our experience, we can usually not neglect, but don't overthink too much what's going on outside of the main beam. And outside of the main beam will depend on the application. Sometimes we will consider the 10% equivalent beam angle, which is exactly what we are doing to compute the CCI result. But for some other application and some maybe more demanding application, I mean, for example, high-end shop lighting, customers will be mostly focusing on the 50% beam angle.
All right. So Theo, I see you're responding on the answer from Laurent. I think we'll publish, or we are publishing the contact of every speaker on the current slide. If you want to contact Laurent and discuss about that with him directly, I think he's happy to answer your questions.
I will for sure. Thank you, Theo.
Okay. There seem to be no more questions from the audience now. So in the end, I would like to say again that we really enjoy working with all of these brands together. So the partnership that we're having with them is really good, really close. And obviously we are offering the whole portfolio of each manufacturer. So for you who are attending the webinar, if you have any question on optics for these manufacturers, we're happy to help. Just contact us. And at the end, I would like to thank Laurent, Michael, Bernie for doing this webinar together with us. It was great fun to do it together, actually. Thanks, guys. I really enjoyed the time preparing everything. All right.
You're welcome, Peter. Thank you.
Thank you very much, Peter.
Thanks, Peter. Thanks for your invitation.
Okay, and thank you, and have a good day, everyone. Bye-bye.
Goodbye.
Thank you very much. Bye-bye.
Have a good day. Bye-bye.